Hi everyone, my name is Lamul Wiset. I am a representative of Nattapol Poomsa-ad. Today I'm going to present our research entitled Pineapple Drying Using Microwave Combined with Hot Air at Different On-Off Patterns of Magnetron. This work is collaboration between Faculty of Engineering Mahasarakham University and School of AgroIndustry, Luang University. Phulae is a popular pineapple. Its geographical indication growing in Nang district, Chiang province. The fresh Phulae is higher price if the diameter of pineapple is about 5 centimeters. If it's bigger than this, the price is lower. And in some season, pineapple is over demand, so the price is also decreased. It's better to dry for further storage or further product. And we found that dry pineapple has unique attributes and suitable to be souvenir. And if we dry the pineapple with the traditional method at about 50 degrees Celsius, it takes quite long hours to 25 hours. So we found that if we use the other techniques, the drying time should be reduced. We are interested in microwave drying. If we compare between the traditional and the microwave, you can see that inside the material there is the water, which is a polar sample, and you can see that when the traditional method, when it's heated by the hot air, the molecule of water still stays still because there nothing activated the movement, like the heat is conduct from outside to inside the product. While as for the microwave heating, the polar molecule of water is movement and changing when it's heat with the microwave, and this is the reason why the water can evaporate from inside to outside rapidly. In this picture, it's clearly seen that the heat flow and mass flow of the sample when compared between conventional and microwave, the heat flow from outside to inside. But the microwave, the heat flow is from inside to outside, which is the opposite way. But the mass flow is moved from inside to outside, the same way. And for the microwave heating, the temperature inside the product is higher than the temperature at the surface. This because of the inside the product, it contains a lot of water, not like conventional drying, which is opposite which is occur in the opposite way, that the temperature outside the product is higher than inside. And we designed the dryer using the Magnetron is available in the market. The commercial one with the 2 kilowatts Magnetron is about 5,000 baht, whereas the 1 kilowatt Magnetron is only 600 to 1,000 baht, which is much cheaper than the 2 kilowatt. Our objective is to compare the use of 1 kilowatt for 4 magnetons by connecting in different patterns of on-off magnetron. For example, position of magnetron and on-off time. Also, the quality of product was evaluated. Material and method. Here is the experimental dryer. You can see that there are 4 magnetrons at the back of the dryer in the drying chamber, and the air inlet from this way pass through the heater and go through the drying chamber and come out. This dryer, we don't use the recycled air. For the Phulae pineapple, it was lined with the thickness about 1 centimeter, and it placed on a 7 tray from the top to this one. For the last one, we didn't use it because it's quite low than the magnetron, the position I mean. For the magnetron's pattern, we use 4 patterns, which is 4 magnetons all the same time, on and off for 30 seconds, and 4 magnetons on and off 15 seconds, and 2 magneton on the top and 2 magneton on the bottom, are alternative on off 30 seconds and 15 seconds. The drying conditions that we set as the same treatment, it's combined with the drying temperature of 60 degrees Celsius, air velocity 0.5 meter per second. The rotation speed of train 10 rounds per minute. 7 days with 5 kilograms of pineapple per batch. Drying time 4 hours. This is from our preliminary work. Found that the pineapple has the AW lower than 0.6, so we fix the drying time to compare the other attributes. Why has to be 0.6? Because if we would like to keep the product for the longer storage, the AW should be lower than 0.6. After drying, we determine the moisture content, water activity, and diameter of pineapple. And we also determine the energy consumption, which is one of our aim that we would like to save energy. We determine from 3 phases using the digital electric meter, and we determine the specific energy consumption. We calculate from total energy consumption divided by water evaporation. Results. This table shows the AW and initial moisture content and final moisture content of pineapple obtained from different conditions. You can see that for 4 hours, AW is lower than 0.6, which is good enough for storage. And initial of moisture content is higher than 80%, and a little bit, some sample is a little bit lower than the other. This is the natural. And final moisture content, we found that if the on-off time is 30 seconds, the moisture content is lower than 15 seconds, but not much different from the 4 magnetons on and off. For the diameter of the pineapple, after drying, the the sample is smaller, but the ratio is reduced in the same ratio from each sample. So it means if we have the big one, it's reduced to small in the same proportional. And for the energy consumption, we as I mentioned before, we measure from the heater, the main source from the heater and from the magnetron, and we found that the energy consumption is a little bit different, but it showed that if we use the choo-choo for 15 seconds, it's less energy consumption, but the moisture content is still high. So the moisture content for the lower moisture content is the 30 second on and off, and for the moisture evaporation it's quite similar, and the specific energy consumption is a little bit different, but still in the same range of 0.033 to 0.037. Lastly, I would like to draw your conclusion of our study. We found that the final moisture content of pineapple from two magnetrons work in alternating top and bottom pads for 15 seconds and off for 15 seconds, still had high moisture content of 14.6% wet basis, whereas the other condition has similar moisture content about 10% wet basis. The drying condition had no effect on diameter reduction. Specific energy consumption was in the range of 0.033 to 0.037. Sorry about that. Megajoule kilogram of water evaporation. Lastly, I would like to thank the Faculty of Engineering, Mahasarakham University for financial support. And thank you for your attention. And Ajahn Nattapol will answer all the questions with pleasure. Thank you.